Hello friends, you're welcome to my YouTube channel. We have a very interesting equation on the board. This is an exponential equation, but it has logarithm in it. We are asked to find the value or the values of x. Without wasting much of our time, let's go to the solution. So in order to solve this question, we just write solution. The first thing we'll attempt to do is to resolve this part, the part that has logarithm. We can write this as 2 raised to the power of log. This 4x will become 2 raised to the power of 2x to base 2 minus, we'll repeat this one, 3 raised to the power of x is equal to 7. Now when we get to this point, we're going to apply two rules of logarithm, two laws of logarithm. First law states that when you have log a to base a, the answer is 1. Log of any number when the base and the logarithm of a number are the same, then the value is 1. The second rule we're going to apply is when you have, let's say you have log a raised to the power of x to base b, you can write it as x log a to base b. So these are the two laws we're going to apply in order to resolve this part of the equation that has logarithm. So let's apply it here. This becomes 2 raised to the power of 2x log 2 to base 2 minus 3 raised to the power of x is equal to 7. Going further, log 2 to base 2 becomes 1. So this equation will automatically become 4 raised to the power of x minus 3 raised to the power of x is equal to 7. So you can see that by applying these two rules, we have successfully resolved the log that is involved in this equation. We now have a straightforward exponential equation. 4 raised to the power of x minus 3 raised to the power of x is equal to 7. So we'll proceed from here. We can write this as 4 raised to the power of x minus 3 raised to the power of x is equal to 3 plus 4. 7 is the same thing with 3 plus 4. So we'll just change this 7 to 3 plus 4. So from here, we can go further. We can go further from this place. This becomes 4 raised to the power of x minus 3 raised to the power of x is equal to 3 plus 4. I just repeated this anyway. Repeated this. So from this point, we can move this 4 to this part of the equation and move minus x to the other part of the equation. When we do that, this becomes 4 raised to the power of x minus 4 is equal to 3 plus 3 raised to the power of x. Okay? We can rewrite this equation this way. 4 raised to the power of x divided by 4 times 4 minus 4 is equal to 3 plus 3 raised to the power of x divided by 3 times 3. We can do this because 4 divided by 4 is 1, and any number multiplied by 1 is the same number. The same argument applies to this. 3 divided by 3 is 1, and when we multiply 1 by 3x, the answer is still 3x. From this point, we can still simplify this equation further by applying a rule of indices. When you have a raised to the power of b divided by a raised to the power of c, according to indices, we can write this as a raised to the power of b minus c. Mind you, if I put 1 here and 1 here, I'm not wrong. Okay, because any number raised to the power of 1 is still that same number. So we're going to apply this now to this equation, specifically to this part, where we have 4 raised to the power of x divided by 4 raised to the power of 1. And also this part, where we have 3 raised to the power of x divided by 3 raised to the power of 1. When we do it, we're going to get 4 raised to the power of x minus 1 times 4 minus 4 is equal to 3 plus 3 raised to the power of x minus 1 times 3. Okay? When we get to this point, if I add this part of the equation, these two terms in this part of the equation have something in common. They have 4 in common. So I can factorize 4 out of this part of the equation. I will have 4 out of the 4, open a bracket, 4 raised to the power of x minus 1, then minus 1, close the bracket, is equal to 3, 1 plus 3 raised to the power of x minus 1. When we get to this point, we are going to apply another basic mathematical rule or basic principle or fundamental principle of mathematics. Let's say you have 5 times e is equal to 4 times f. For this equation to be correct, it means that e must be equal to 4 and 5 must be equal to f. This 5 must be equal to f and e must be equal to 4 for this kind of equation to be correct. What we have here is similar to this. So with this knowledge, we can apply this, what we got here, to this equation. When we do that, we are going to get 4 is equal to 1 plus 3 raised to the power of x minus 1. That is, this 4 here will be equal to what we have here, just like 5 was equal to f. I'll label this as equation 1. Then 3 must be equal to what we have here. So 3 is equal to 4 raised to the power of x minus 1 minus 1. I label this as equation 2. If all our steps are correct, after solving these equations, equation 1 and 2, the answer we'll get for x in equation 1 must be the same with the answer we'll get for x in equation 2. So this is the final stage of our problem, the solution to our problem, where we will solve for x directly. Starting from equation 1, we can rewrite equation 1 as 4 minus 1 is equal to 3 raised to the power of x minus 1. How we got this is that we moved 1 to the other side of the equation. 4 minus 1 is 3. This is equal to 3 raised to the power of x minus 1. This is also raised to the power of 1. When the bases of an indices are the same, you can equate the powers. So we can write 1 is equal to x minus 1. Then x will be equal to 2. If we apply it the same to solve equation 2, we can move 1 from this part to this part. So we're going to get 3 plus 1. This is equal to 4 raised to the power of x minus 1. 3 plus 1 is 4. So 4 is equal to 4 raised to the power of x minus 1. This is also raised to the power of 1. In the same way, just as we applied here, when the bases are the same, we equate the power. In this case, the bases are also the same. So we can equate the powers and have 1 is equal to x minus 1, which also implies that the value of x is equal to 2. So our answer is x is equal to 2. I hope you enjoyed the video. Thank you for watching, and keep watching our subsequent videos. Bye.